and welcome to the live stream. My name is Kendra Little, and I am a DevOps advocate at Redgate. And I'm working on my live streaming setup. So hopefully, fingers crossed, I've changed my setup around a little bit. We'll see if we get good video quality on this one. Today, I wanted to talk about a question that came up about monitoring SQL Server instances and about forecasting for the future. And the question was about whether or not you can project CPU usage and whether or not you should project CPU usage for relational database servers like Microsoft SQL Server or similar other relational database engines. So part of the reason that this comes up is that we do have some monitoring features for projection in our products. So for example, in SQL Monitor, Redgate SQL Monitor, on the estate pages, you can go to the disk usage page and it looks at, okay, how much disk space are you using? What's the capacity? And it does some projections about how much space will you be using over time and how long will it be until it's full. So, I mean, this is very cool. And the fact that this is very cool, of course, inspires you to be like, well, what other things could we do this for? So the tricky thing is that this doesn't work for everything. So in terms of projecting for CPU usage, here are the things that make CPU usage particularly tricky to project and I would say incredibly difficult, if not impossible at this point, to reliably project for SQL Server. And a lot of this just has to do with how performance works in SQL Server. Performance in SQL Server can change dramatically very suddenly, even if you aren't changing the schema of the SQL Server. And it has to do with a variety of factors. So SQL Server is running along. Performance is going well. How do we tell performance is going well? Usually this means our users are happy with the performance they're getting, right? So low CPU usage doesn't necessarily mean performance is good. High CPU usage doesn't mean it's bad. How we tell performance is good is by having customers say, yeah, this is good, right? Because in fact, we could have very high CPU usage, performance could be great. We could have low CPU usage, performance could be bad because we could have bottlenecks in other areas, right? Like performance is dependent upon many factors. So performance is good and CPU usage, let's say it happens, it's up and down. It's really gradual, but it happens to be around maybe an average of 15% for the SQL Server. Let's say we have a common query. It gets run frequently, and it's something that we can't just cache in the application tier. It actually has to hit the database server. And this common query, suddenly its execution plan that it normally gets, that's normally quite fast, where users are happy with the performance, suddenly that plan changes. Now, why would that plan change? The plan might change for a variety of reasons. It could have to do with parameter sniffing. It could be that something triggers a recompile. Perhaps a change in the amount of data in the table triggers a statistics update. Perhaps an instance failover triggers a recompile. Perhaps we restart because of patching, and maybe that's failover, maybe it's not, right? But a variety of things could cause a recompile, including just changes in data. If we happen to get, for the next time that procedure's run, or this could just be a parameterized query, you don't have to use stored procedures for this to happen. This commonly run query, if it happens to run the first time the plan is put in cache, if it happens to run and get an execution plan that is of a different nature than the one we usually get, CPU usage could change dramatically at the drop of a hat. And I've seen this happen many times. I've been called in to troubleshoot, hey, sometimes the system is really slow. And during these times we have, whoa, this high CPU usage, what's going on? And then suddenly it drops down, right? This is something that can happen just due to the nature of recompiles, which can be triggered just by data changes or by restarts, and the nature of parameter sniffing. And By the way, the moral of this story is I'm not telling you not to use parameters. You run into other problems if you don't use parameters, but I am just saying it is actually not unusual for CPU usage to be very choppy in its patterns. Hey, things are good for a while, and then suddenly they're way bigger. Now, the response to, hey, suddenly CPU usage is way higher, this shouldn't be, hey, just add more CPUs, right? So one problem with projecting CPU usage is it's not going to be reliable. And I've given you the example of parameter sniffing. There's also just examples of, hey, we added an index and it went way down because now we're able to do things more efficiently, right? How could you project that you were going to find an index to add that suddenly dropped the CPU usage, right? So it's incredibly difficult to project the nature of this due to things that just happen, as well as impacts that your code changes might have. But also, the reason that it's useful for this disk-based report, the reason that it's so useful to kind of project this is from a capacity system where we can project this, where for many systems it is going to be reliable, like, oh, these are the patterns about how things are growing. We want to use the projection for capacity planning for the next year. And this is generally, I wouldn't do capacity planning for CPUs in the same way as disk at all. I wouldn't just project and say, it looks like it's going to be this much, so we should buy this much more. And the reason I wouldn't do that is you can run into the error of way overspending. This is because, well, first of all, our projections may not be right, but then second of all, CPUs is a very expensive area to start projecting about because often we aren't just talking about what are the costs to buying more CPUs. The cost isn't simply a hardware cost. The cost usually also includes a licensing cost. For the Microsoft Data Platform, a lot of times we are licensing by the CPU and saying we're looking at a projection and we're going to buy this many more CPUs. This could be incredibly expensive. What I would say is worth doing instead, right? So having this projection can just lead us down this very expensive, wasteful path. So what I think is really worth doing instead for CPU usage is saying we are going to review, hey, what's our CPU usage been over a period of time? For places where performance is important, we're going to prioritize a quick exercise of looking at, are there ways we can actually drop this CPU usage down quickly with minimal work? And the ways that you can do this, there's actually multiple levers. Are there indexes that can dramatically reduce the CPU usage of the workload? By adding 1 or 2 indexes, I have taken SQL servers that had 60% regular CPU and dropped it down to 10 to 15% average, which is a very healthy pattern of spiking up and then staying really low and periodically spiking up, not constantly elevated, because indexes have that much influence on the performance of a workload. So yes, looking at where is CPU going up can be useful, but not for projecting future CPU, for instead looking at, hey, where do we need to prioritize tuning if performance is important? In addition to index usage, you want to also think about what are the parallelism settings on this instance. What are the weight stats on this instance? This will help you out too. And we have that over in the overview section over here. You want to be looking at settings like this, and let's see if I can drive and talk at the same time, because we do have some live workloads behind this site. You want to be looking at things like, we've got 18% CPU here, so we'll go into this node here. Things like, is the cost threshold for parallelism setting at the right level so that only the queries that really need it go parallel? You might overuse a lot of CPU, and I'm going to go here to the top 10 weights just so that you can look at things like how many, what is your level of parallelism weights on the instance? And there may be multiple types of this depending on what version of SQL Server that you're on. They've broken CX packet into multiple types, but if you don't have any CX packet weights, by the way, you probably don't have any parallelism at all, because CX packet, you can get a description here. It's related to the amount of parallelism happening. having parallelism weights isn't necessarily bad or good. This is one of those things where they split this into CX packet and CX consumer weights. And now they show you, this breaks down what versions it is, and now they show you the CX packet weights. With CX packet weights, yes, maybe this is something you can tune. You want to look at it. Having some parallelism weights, what you really want is how do I make the queries the fastest, right? Not how do I reduce the weights. You could reduce the weights the most by removing parallelism, but then you're saying, hey, my queries can't use as many threads. So in thinking about this, you really want to look at, am I having parallelism? What is the threshold? What is the cost threshold for parallelism? Because really, I only want the queries whose estimated costs show that they need it to actually go parallel, right? And that very much impacts how much CPU am I using. If I'm letting all of my queries go parallel, because the default setting for cost threshold for parallelism is very, very low, if I'm letting a ton of my queries go parallel, I'm going to use a lot more CPU usage. I really want just the queries that need it. And this threshold is going to get set at different places on different servers. For the servers that I learned on, way, way back, even before the SQL 2005 days, but SQL 2005 and later, my group had a practice of our default setting for cost threshold for parallelism was 50. That's where we started tuning. And sometimes we make it lower, sometimes we make it higher, but we would start way over that default threshold of 5, which is where it ships at. The number of cores used, the parallelism setting, the max stop setting of how many cores you use when you go parallel, also massively impacts how much CPU is being used on the server. So these are some of the levers you can change. Don't forget about the index tuning. It can be very powerful there as well. But even just some minor tuning of these settings and a quick health check of your indexes can save you tons of money on CPU. And this is the big reason why I'm like, I don't want to really advocate, I'm an advocate. So part of my job is advocating for what is really the best features for the customer. And I feel like I haven't seen the argument yet for how projecting CPU would help you, because in addition to the fact that I'm like, I really don't think that's predictable because of the unpredictable nature of execution plan changes, even with data just changing, but also it will just lead you into this overbuying of licensing, overbuying of resources that probably with some tweaking, you can get that under control, right? And that is an activity that should happen periodically. You're not going to tune this every single day for every single server. This is more of a checkup on your most critical servers where performance matters and where you really want to get the most out of this. The other thing, the last thing, there's a lot of, I think this is a really interesting discussion. I love this question because I think there's a lot of richness in here. But the other thing I think about is when it comes to things like migrating to new hardware, whether I'm using virtualization or whether I'm using physical servers or whether I'm, using whatever, generally, when migrating, we go to hardware where the CPUs are dramatically different than the CPUs on the old hardware. And this is because of things like just advances in processor architecture. It isn't linear, right? So 4 cores using 4 cores in new hardware can be dramatically faster than 4 cores on the old hardware, whether we're accessing it through a virtualization layer, through, whatever. So often when we're thinking about future usage, like projecting just how much CPU power do I need, it doesn't translate to number of cores that we need. Because often when we are moving, we're moving to faster cores where we can do more with less, depending on the nature of our workload. Right? So that's another factor that this is a complex thing. And part of why people get so excited about burstable workloads in the cloud is that it frees you up for some of these things so that if you are in an industry where you have some periods of the year that are really busy, you want more of a burstable architecture, right? So that you aren't paying for these resources all year long. If you are in that kind of industry, you also want to make sure you've got someone who's good at index tuning, you've got someone who's familiar with tuning parallelism and helping you through that period get the most out of whatever resources you're buying that you can. So anyway, I love this question. Thanks to the folks who brought this question up. I really enjoyed talking about this. And this was a fun live stream. So hopefully my live stream setup went well, and I hope to start doing this more often. Bye, folks. I'm Kendra Little from the DevOps Advocate team.